Algebra 2 Cram, New York State, Algebra 2 Regents, Common Core, Complex Numbers, Question 6. Simplify fractions using complex conjugates. Inbox me at memedicine@gmail.com to order your complete cram session. Review Question 6, Complex Numbers. The expression 5 minus I over 7 minus 3I written in simplest A plus BI form is going to be 1, 32 over 58 minus 22 over 58I, 2, 16 over 29 minus 11 over 29I, 3, 38 over 58 plus 8 over 58I, or 4, 19 over 29 plus 4 over 29I. Definitely press pause if you need to, and I'll give you a moment to think. Okay, so let's take a little aside, a conceptual aside to get something straight in our thought process. The conjugate of the binomial A plus BI is going to be A minus BI, and they only differ by the operations separating the two terms, and the operations will be the inverse of each other, that is addition and subtraction. This doesn't apply for any other set of operations, okay? So that's what's special about a set of conjugates. The terms are in the same order, but they only differ by an opposing minus or plus sign, okay? So in order to go back to our original question stem, in order to get this in simplest A plus BI form, we're going to have to rationalize the denominator, because as you can see, the imaginary term I is in the denominator. That means it's an irrational number, because the true value of I is radical -1, and we don't like having radicals in denominators because that means that it's no longer rational. Rational numbers are whole or fraction values with integer numbers in the denominator, okay? But for rational numbers, you can have radicals or imaginary numbers in the numerator. That is allowed, just not the denominator, okay? So in order to rationalize this denominator, we're going to have to multiply by the conjugate of 7 plus 3i, and you guessed it, if we allow 7 to be a and bi to be represented by 3i, then 7 minus 3i is going to be the conjugate of 7 plus 3i. And the reason why we're multiplying by the conjugate of 7 plus 3i is because conjugates yield the difference of squares. So basically, all you have to do basically is square the first term, square the second term, and subtract the second term after it's squared, okay? Instead of FOILing out everything. That's what it boils down to. And this is cool because I squared is just simply going to be -1, because if you square a radical or square a square root, you're canceling out the unwritten index of 2 by raising the term to the exponent of 2 after squaring it, which is what you're doing in essence here, okay? So we basically are going to get, after we FOIL the numerator, and square the first term in the denominator as well as the second term. And in order to square 3i, you just basically square 3 and square I, and you get 9i squared, okay? And then let's just go through the steps in FOILing the numerator. If you multiply 5 times 7, the first term, you get 35. If you multiply the outer terms, which are 5 and -3, you get -15, well, -3i rather, you get -15i. If you multiply the two middle or inside terms, which represents the I in FOIL, you're going to get -7i. And if you multiply the last terms, well, you multiply 3 by the invisible coefficient of 1, and you multiply the I terms by each other to get 3i squared, okay? And remember, you might have to watch the previous cram sessions in this particular collective on complex numbers to see why I squared is -1. So that's what it's going to simplify down to, okay? All right. Actually, I'm not sure. I think this should be, yeah, you have +3 up here, and then when you simplify I squared to -1, because remember, you're squaring radical -I, so that's why you're getting -1. You get -3, and here you get -9, okay? So, and we also combine the I terms in the numerator. Now all we have to do is go ahead and subtract a -9 in the denominator and subtract 3 from 35. And we get 32 minus 22i is over 58, but that's not the form that we have here. So we're going to have to separate these fractions. So we're going to have to yield 32 over 58 minus 22i over 58, okay? And the reason why we're doing this again is because we want to follow the formatting structure we have in the multiple choice answers. And we still don't see our answers, but what we can do is we can factor out 2 in the numerator and the denominator of both terms, okay? The a term, which is strictly going to be a numerical constant, and the I term, which has a coefficient and the imaginary number I. And this is what we end up with, 16 over 29 minus 11 over 29i, and that's going to be answer choice 2. All right, so the correct answer choice is answer choice 2. Thanks for tuning in, and good luck studying.